Jobsheet number 2 for cutting, threading, and cleaning the galvanic pipe. The equipment that we would like to use here is pipe cutter, boring reamer, dies to make a thread or screw for 3 and 4 diameter and 1 to 4 diameter. This is the holder of the dies. This is brush for clean up the pipe. Marker for measuring, give a mark of the measured pipe. This is screwdriver for cleaning the pipe. This is plier also for cleaning the pipe. The meter. This is the vise or clamp to hold the pipe. And the stand for holding the pipe. And grease to make the screwing process easy. The material used are the galvanic pipe. This is the diameter is 3 to 4. And finally, this is the result that we will make in this job sheet. The cutting in this side and screw. That's all the explanation.
This is the working instruction. First, measure the desired pipe length with roll meter and marker. 2. Set the pipe on the vise and stand. Tighten the vise. Put the dies in the wrench. 5. Cut the pipe with manual pipe cutter. 6. When the pipe is cutting using pipe cutter, the diameter of the pipe will narrow. To restore the shape, using the bearing reamer for maintaining the size. 7. Apply the dies in the threader to the pipe to make 10 external straight thread. Drip with grease to make the process smoother. Remove the dies. Apply bearing reamer. Use plier and file tools to clean up the screw if necessary. Finally, clean the iron powder and oil with wire brush and cloth. In the chapter 3, we learned the layout of drainage network. The learning outcome of this section, a student is expected to able to describe the drainage network, including channels and structure, according to the technical drawing standards. And next, you are expected to be able to design the layout of channel, the placement of the channel and facilities in a residential area effectively. The definition, yeah. Urban drainage network is all wastewater flows from natural and man-made channels. And drainage network is the layout of the channel and the structure in a, presented in a map. So in this chapter, we would like to draw a drainage layout map like this. So for drawing the layout, we need the situation map, the layout plan map, including the location, the position of the housing area. So this is the block of housing area or residential area, A, E, G, H, L, and so on, stand for the name of the block. So in between the block, there are roads, and also this map has a contour map or topographical map like this. This is the topographical map showing the contour map. You understood already the contour map. Contour map is a map that has a contour lines, which means a line that shows a location which has the same elevation. So when we follow this line coming to the directions, it means all the location of this line has the same elevation, which is 62 meter above mean sea level. This one 61. So the interval of this contour, we say the interval is 1 meter, which means the elevation difference between this line and this line. The layout of drainage network consists of the line itself. This is the lines of the channel, which means the position of the channel. We call it the trace. And also the direction of the flow, which flows from the higher to the lower. And also the culvert like this. This is culvert. Culvert shows the channel that cross road or any other facilities. So normally this channel is a closed channel. Closed because it crosses the road, so we must use a closed channel, culvert or gorong-gorong. In Indonesia, in Bahasa we say gorong-gorong. This is the layout plan of the typical road. Normally, the drainage channel is located in the side of the road. When this is road, so the channel is here and also somewhere here. So in the left and right side of the road. When we make a cross-section of this road plan, we can see that the road has an axis. This is the axis of the road, and the road has a slope to the left and to the right about 1 to 3%. 1 to 3%. The purpose of making the road slope is to allow the water when we have a rainfall above this road, so the water will be easily discharged to the side channels. So in this case, the channel shape is a round and it is not an open channel. So this is another example of open channel like this, open shaped channel, not open channel. We usually say open shaped channel. The same that the road should have a slope to the left and to the right.
So what we want to design here is the channel in the left. When this is the direction of the flow, we design the channel here and also here. The data needed for making the drainage channel network map is a topographical map with the interval of 1.5 meter. It is very good if you have 1.5 meter interval, but 1 meter is also enough. You also need the drawing of road plan and cross-section of the road if you have. Also situation map which shows the facilities and land use. Land use means the land cover, which is housing or maybe garden or cemetery or school or mosque. Any facility should be shown in the map. And if you design the major drainage channel, you need the city master plan. The criteria of the layout of drainage network, you have to make sure whether your area has a mixed or separated drainage system. Mix means between the rainfall, rainwater, and wastewater. In Malang, unfortunately, as I explained to you in the first chapter, we still combine the rainwater and wastewater. It is not good actually. But some housing area, which is a new residential area, they already separate the wastewater, and the wastewater comes into the wastewater treatment plant first before discharging to the drainage channel. So we assume in our case, we use this combined water system. And the second criteria, we have to understand which direction of the natural flows come. We should understand the situation even we do not come to the location. We do not do a survey, but we have to understand by checking the contour map. Which direction is the flow will comes naturally. So it should come to the river normally, a river or lake or sea, because they are naturally located in the low land area. So the third criteria is the road location and road facilities, because when you understand the road, you will easily put the channel normally in the left and right side of the road. And other important criteria is the local characteristic, whether you have an existing network of public facilities, for example, irrigation, electricity, clean water, and you may already have some existing pipe there. Criteria. The steps of making the drainage layout map is first, you have to draw the drainage line, the trace line first, and you determine the elevation of each channel in the upstream and downstream. In this case, you have to use interpolation again. But the interpolation here is not a table, but the contour lines. After that, you define the flow direction, of course, by using gravitational flow. We decide the flow direction from upstream to downstream or from the higher elevation to the lower elevation. Number 4 is you place the culvert in the cross with the road. Then you make a number of each channel, and finally you determine the final disposal. It means the major drainage channel or the river. This is the final outlet of our drainage system. This map is produced by Ministry of Public Works Indonesia. It is an old map produced in 2004, I think, 2003. But the contour map or the topographical map is usually fixed. Unless we make a land grading or we make a cut and fill too much. But normally, because contour is the earth surface form, so it is usually not changed, even this map is old. Yeah, so this map number is J17. J17 means the code of this map. So you can see from this index map, this is the boundary of Malang City, the purple or black color boundary of Malang City, yeah, not Malang Regency. So normally we take one grid for our analysis for the assignment. So what is this? J13? J17? J17 is here, the red grid. One grid is one sheet of map. So J17 is here, this is J and this is 17. So when you need other map above this grid, you should request to me J16. But I think one map is enough for all students. Yeah. From this map, we can see the contour lines shown by yellow or orange color. Yes, this is yellow. This is orange. Yeah. If you want to know the elevation of each contour line, you click to properties, right click and see properties, and you will see this box. Yeah. From this box, dialog box, you can see the elevation is 430 meter above wind sea level. So the interval is, let's see the next lines, is 429. This one 428. This one 427. So the interval is 1 meter. I hope you already understood how to read the contour map. Maybe you learned already from topography course or from the surveying course. Let me explain the characteristic of this area by reading the contour map. When the contour lines are close each other like this, it means this area is a steep area. Steep means the slope is big. It is correct because there is a river around here. This river is called Kalimetro. The direction is from top to down or from north to south. So when the land is close to the river, it is usually has a steep slope. Yeah. So that's why the contour is close each other here. When the contour is dense like this is a steep slope. Yeah. When the contour is far, the distance is far one to each other like this. Yes, coarse or far. It means this area is relatively flat. Yes. So when you get number 3, for example, absence number 3, you have a flat area. But number 7, your area is steep because there are many contours located on this block. Yeah. This is the example of one block that we will design the layout of drainage network. The block is marked with red color. So at first we have to understand first where is the final outlet, the final channel that we would like to discharge this water. Yes, because in the left side there is a Brantas River basin, so we can assume that the direction of the flow should be to the south, because Brantas River is also moving from the north to the south. And also to the left, because the location of the river is in the left side. Yes, like this. So should be to the left and to the south. When we make the zoom of the block, it shows this kind of condition. There are several contour lines located on this block. For example, this one contour line. This is also another contour lines. This is also another lines. So at least 3 lines are here. So this location is relatively steep. First, we have to draw the trace of the channel by making offset, and I give the color of blue here. You offset the line of the housing to the outside of the block, and we show with the blue line here. Then you put the node. The dot here means the node. When the channel is turning or bending or crossing, you should add one node for one bending or one crossing, at least. So basically, more node we make, more accurate our calculation will be. Then the next process is interpolating the contour. What this interpolation means? Yeah, we want to know what is the elevation of this dot, this point. We have a contour in this place and in this place. Yes. No, there is no contour exactly on this point. That's why we have to calculate the interpolation. How to do that? We check first what is the elevation of the left contour. The elevation is 420. So this is 420 contour. And what about the right side contour, this one? We check from the properties, it is 421 meter contour. So this one is 421. So when we guess the elevation of this point or this point, it should be between 420 and 421. Maybe it is 422.6, maybe. But we have to calculate accurately. So let's move to the calculation of contour interpolation. This is example of different contour lines. So we want to calculate the right points here. So this is the left bottom, this is the right top. The interpolation of the contour is made by measuring the distance between the high contour. This is the high contour. Low contour. This is the high contour. Yes. Low contour is 423 and high contour is 424. And we want to know this dot, what elevation. We measure first the distance between the low contour and this dot, this point, by using the function of distance in AutoCAD. This is the distance. Distance, or you also can use dimension. Yes. By using distance, you can see the length is 2.549 from the low contour to the point. And we also measure the point to the high contour. By using distance again, we can get the information of the distance. It is 17.484. So after that, we make the ratio of the triangle like this. This is the low contour, this is the high contour, and we want to know how much the elevation of A or this point. So we put the distance from the low contour to the point and distance of the point to the high contour, and we make the equation like this. This is the simple ratio of triangle. Very simple. You can do manually like this by calculator and make a comparison or ratio like this, or you also can use Excel by using the formula of forecast, the same as you interpolated the table. So the ratio, if you use the manual calculation, the ratio of the horizontal, the short distance to the overall distance will be the same as the ratio of the unknown point to the lowest contour and the highest contour to the lowest contour. The ratio of this is the same as the ratio of this. After that, we make a simplification of the equation, and this is a simple mathematics. And after that, you will get the A elevation. The next step is drawing the channel direction and numbering the nodes and placing the culvert. After we finish the interpolation, we will get the elevation of all points. So you you write the points on this map. Each point should have an elevation. After that, you check the flow direction. Of course, the direction will be from the higher to the lower. We give a mark of the direction by using this arrow. One channel, one arrow is enough. No need to put many arrows to avoid the complexity of your drawing. Then next step is you put the number of the nodes as an identity of the node. 1, 2, 3, 4, 5. Normally we give a small number in the upstream and big number in the downstream. Then after that, you decide the location of the culvert. This is culvert here. The culvert location should be in the lowest point. The lowest point is number 4. Yeah. So from number 4, which direction we should make the water flows? Can be to the left and to the down, either to the left or to the down, because we check from the river direction. From here, you remember, the river is located in the left and the direction is from top to the down. Actually, we also can draw the culvert to the down like this, to the bottom, but we select the shortest path. In this map, to the left is the shortest. So we make a culvert to the left, and don't forget also to put the flow direction. And put the new number 5 for the downstream of the culvert. The next procedure is finding the final outlet of this block. Yes, of course, we will discharge the rainwater from this block to the Brantas River stream, but we have to find the correct path. So it should be in the left or right side of the road like this. When the road is stopped, when it comes to the end of the road, because this is end of the road, you should find the way in between the housing. You should not cross the housing to make a channel. Yeah. For example, you put like this is not good. Yes, you should find the proper path of the channels and put the flow direction, and it is done. It's finished for designing the drainage network layout. After this, we continue the calculation to the design flood analysis.